This PowerPoint is called Discovering Engineering by Evan Clark, a member of the STEM Academy in 2013 to 2014. What is engineering? Engineering is a problem-solving process. Engineers use principles of design and production to meet human needs and wants and solve human problems. Engineering is split into major branches, of which there are 4 major branches that we are going to discuss. The first is chemical engineering. It includes the investigation and production of various chemicals. Engineers in this field investigate and produce these chemicals and apply principles of physics, mathematics, chemistry, and engineering to their work. Chemical engineers work in specialized fields that are very diverse, such as pharmaceuticals, manufacturing, healthcare, petrochemicals, food processing, polymers, and biotechnology. Chemical engineers apply their knowledge not just to designing and producing products, but also to the law, medicine, finance, publishing, and education, as well as other fields that require technical training. Problems that chemical engineers might have to solve relate to the production or usage of chemicals as well as various other products. For example, chemical engineers might have to solve problems such as determining how chemicals will impact the environment, how technologies that are cleaner can be developed, and how objects comprised of chemicals can be improved. Engineers in this field may have to work on projects relating to the finding and production of chemicals, such as fibers, fuels, paper, semiconductors, fertilizers, medicines, paints, and plastics. The second of the main engineering disciplines is called civil engineering. This is one of the oldest engineering disciplines. Civil engineers provide oversight for buildings and infrastructure's construction. They provide the oversight for these sections of infrastructure that comprise many aspects of our lives. Civil engineering is divided into 7 specialty areas. These are structural, environmental, geotechnical, water resources, transportation, construction, and urban planning. Engineers in this field may design and oversee construction of highways, different kinds of bridges, skyscrapers, tunnels, water reservoirs, public buildings, and railways, among other forms of infrastructure. Engineers in this field might have to solve problems like determining buildings' expected lifetimes and their construction cost. Engineers that are civil engineers might also have to deal with government regulations on projects and potential environmental hazards such as earthquakes and hurricanes effects on projects and civil infrastructure. Engineers in this field may encounter projects such as designing some of the world's tallest skyscrapers, developing buildings that withstand natural disasters, or laying out infrastructure that could lead to decreased travel time or less congestion in public areas. The third of the main 4 branches of engineering is electrical engineering. This is engineering's largest major field. It involves the design and construction of systems that use electrical principles. Electrical engineers design, develop, test, and supervise the manufacture of electrical equipment. They traditionally have focused on the generation and supply of power, and specialize in areas such as power systems engineering or electrical equipment manufacturing. Engineers that are electrical engineers may have to deal with problems like electrical airplane safety devices. They may also have to deal with developing electrical technology that allows a cell phone to operate, that harnesses energy, or that transports that energy to an area that needs the energy in the form of power. Engineers in the electrical field may have to work on projects relating to the development of digital cameras, cell phones, MP3 players, wireless types of communication systems, medical tests that involve electrical processes, medical imaging, robotics, roller coasters, and various computer networks, among other important design and production projects. The fourth and last of the main engineering disciplines is mechanical engineering. This is one of the largest, broadest, and oldest engineering disciplines. Mechanical engineers design and develop any product with mechanical processes. They work on just about all areas of technology, and they create technological and industrial systems that drive technology and industry. They deal with computer technology, biotechnology, automotive technology, and aerospace technology. In particular, mechanical engineers research, design, develop, manufacture, and test tools, engines, machines, and other mechanical devices. Mechanical engineers solve problems in machinery. They deal with problems including creating specialized devices. They can provide important medical breakthroughs that are highly desired consumer products or much needed military machinery. Mechanical engineers work on products such as developing transportation systems mechanisms, or developing aircraft carriers, tanks, jet fighters, hybrid car engines, sailboats, wheelchairs, bike locks, toys for children, mechanisms that power factories, or devices used in medical procedures. Besides these four major engineering disciplines, there is another discipline of engineering that is minor, but is a combination of principles of civil engineering, mechanical engineering, and electrical engineering. This is architectural engineering, and I've always been interested in this engineering development. Architectural engineers use principles of engineering to solve problems and provide oversight for the planning, design, and construction of infrastructure, chiefly buildings. Often, architectural engineers help to determine buildings' abilities to withstand natural disasters, like earthquakes, or work on the design, analysis, and efficiency of systems such as heating, ventilation, electrical, lighting, plumbing, and fire protection that help buildings function. They work on building systems, as you can see. Architectural engineers apply principles of civil engineering, mechanical engineering, and electrical engineering to their work on buildings and the systems that allow them to function effectively. In many ways, architectural engineering is a specialization of civil engineering due to the importance of buildings to this field. While civil engineering is more generally concerned with infrastructure as a whole, architectural engineering deals more with just buildings. You might ask, well, what do engineers achieve? What kind of differences have they made in the world? Well, one of the greatest 20th century engineering disciplines was the development of laser and fiber optics. To begin with, Charles Towns deduced the basic ideas about lasers, but originally intended for them to be a tool to produce types of radio or infrared waves that would investigate characteristics of molecules, such as behavior and structure. He did not originally intend for lasers to have a role in engineering. However, Towns and other researchers at Columbia University received the desired output from the radio waves by exciting lasers through the use of ammonia gas. And over time, these researchers found many ways to excite laser beams into action. Once a laser beam is produced, it shoots an extraordinarily thin and powerful beam of light that can have a multitude of uses in medicine, manufacturing, radar, CD/DVD discs, and in freezing molecules and movements during the processes of chemical reactions. Research into fiber optics communications have greatly helped the development of lasers as tools in long-distance communication. And lasers today have a great variety of engineering uses. Out of the four major engineering disciplines, chemical engineering, I believe, is most involved in the development of laser and fiber optics. For example, chemical reactions such as ammonia gas played a key role in finding ways to excite laser beams. Many useful lasers today, such as infrared carbon dioxide lasers and argon lasers, use chemicals to excite the beams of light. Fibers are in the realm of chemical engineers. Chemical engineers actually design fibers. And fiber optics, a clearly chemical development, has been heavily influenced by lasers on its path to becoming a long-distance communication tool. An engineering grand challenge for the future that is very important to our world, I believe, is restoring and improving urban infrastructure. This challenge is within the scope of architectural engineering and relates to modifying urban infrastructure and restoring architectural efficiency. Or specifically, I'm quite interested in this grand challenge because I believe it is very important to modify urban infrastructure and restore architectural efficiency and refinement. This grand challenge is very important to the world because aging infrastructure in the United States and in the world as a whole is no longer effective. Funding thus far has been far too insufficient to change the current infrastructure dilemma. Therefore, engineers must face the challenge of modernizing American and global infrastructure. Engineers will have to solve dire problems in this grand challenge, such as finding solutions to the support problems encountered in Asian megacities' infrastructure, ensuring infrastructure can survive the very natural disasters that pose a threat to its security, and molding future infrastructure to be environmentally sustainable. In addition to these major problems concerning infrastructure, engineers will have to deal with the prospects of efficiently engineering massive, heavily integrated transportation systems, which must be improved in order for cities to function well, and engineering urban revitalizing areas that will increase sustainability and increasing positive urban appeal by employing increased aesthetics in architecture. A solution to this challenge is very important to the world because if a solution to this challenge was generated, infrastructure for millions of people would be able to actually support the Earth's rapidly growing population, which it is not able to in the current condition of Earth's infrastructure. Infrastructure in its current state is at risk of being destroyed by natural disasters or acts of terrorism, and therefore must be modernized and made more efficient. A solution to this challenge would greatly reduce the impacts of environmental damage caused by much of the infrastructure of today. It would increase the cleanliness and sustainability in rural cities. Finally, a solution to this challenge will provide for more orderly, manageable systems of high-tech infrastructure, increase the efficiency of much-needed transportation systems, and contribute to greater urban appeal through the use of deliberately planned aesthetical architecture. If I was an architectural engineer, I would have a major role, possibly, in developing a solution to this challenge. Architectural engineers deal with infrastructure, and so there is a good chance that they would have a major role in determining solutions to this challenge. If I was an architectural engineer, I could contribute to a solution to this challenge of restoring and improving urban infrastructure by designing transportation hubs in cities where multiple means of transit conveniently intersect pathways. This would reduce cities' congestion and confusion, and also locating transportation systems would be lowered significantly in the chances of losing your way. Neighborhood systems in cities would increase cities' sustainability. They would perform the duties of carrying water, energy, and waste all in one system each. They would also relieve pressure to meet the needs of all the citizens of the cities they would service. Finally, as an architectural engineer, I can contribute to the solution of this challenge by incorporating much desired aesthetics such as urban green areas, using the design of landscape to increase water runoff management, better systems for storm drainage, and more effective water purification systems into new and previously existing urban architecture in order to increase urban appeal and decrease pollution. These are the sources that I cited in the making of this PowerPoint, and I hope that it has helped you increase your knowledge of what engineering is and what it deals with. Thank you.